Let's look at the solution. So geometry bias. Now refer to the diagram below, not drawn on the scale. ABCD is a quadrilateral inscribed in the circle such that AC bisects both angles DAB and angle DCB. DAB and DCB. So this is Y. This is also Y. And this is X. This is also X. Okay. If AB is 4 and BC is 3, find the ratio of the area of the quadrilateral to that of the circle. Okay. First thing you need to notice is A and C are opposite angles of a cyclic quadrilateral. So 2x plus 2y will be 180. So x plus y will be 90. So this angle here is 90. Similarly on this side, this angle here is also 90. If this is 4, this is 3, the area here is 6. Also the length of AC is 5. Length of AC is 5. Now, when you look at the triangle ADC, can you see ABC and ADC are congruent triangles? They're of course similar and they share a common side. So area here is also 6. So area of ABCD is equal to 12. The radius is equal to 5 by 2. So the final ratio that you need is area of the quadrilateral to that of the circle. It will be 12 by 5 by 2 whole square, which will turn to 48 by 25 pi, or option C will be the answer. Next, the shape of a solid plastic toy is shown in the figure below. The structure consists of a cylinder, frustum of a cone, and a hemisphere. The height and radius of the cylinder are h by 2 and r respectively. The radius of the hemisphere is r. The height and base radius of the original cone were h and r respectively. When they say original cone, they are referring to the frustum. When you cut off the top portion, you're left with the frustum. So they're saying for the total cone, original cone, the height was h and the radius was capital R. If h is equal to 2 times of capital R is equal to 4 times of small r, what is the volume of the toy? Basically, what this question expects you to do is calculate the volume for each of these figures separately. So first, let's work with the cylinder. Volume is given by pi r square h by 2. This is the volume for cylinder. Now for the frustum, you have to pay attention. It was cut off from something. Sorry. Ideally, it should go all the way till here. It was cut off from something. It was cut off at the halfway mark. If it is cut off at the halfway mark, the large cone and the small cone are similar. If it is cut off at the halfway mark, the ratio of volume will be cubes of the ratio of sides. The ratio of sides here is 1:2. So ratio of volumes will be 1:7. For the bottom frustum, 1:7 or 1:8 total. So volume of the frustum will be 7 by 8 into 1 by 3 into pi r square. So capital R square, and the height was h. This much we know for frustum. Let us now go to hemisphere. Hemisphere is fairly simple to manage. Volume is given by 4 by 3. 4 by 3. So not 4 by 3. 2 by 3 pi r cube. Okay. At this time, when you look at the options, you realize everything is either in small r or capital R. Everything is either in small r or capital R. So these h's need to go. So can I go h is equal to 4r? So if I replace it with 4 small r here, this will turn to 2. So I have 2 r 2 pi r cube here from the cylinder. This h here I will replace with 2r. So this cancels, gives me 4. This is gone. So I'm left with 7 by 8. 7 by 8. Sorry, not 7 by 8. 7 by 12 pi r cube plus 2 by 3 pi r cube. At this time, can you also realize the answer cannot be one of these two? Because in terms of r cube, capital R cube, we are not reaching those huge heights. We are barely crossing 1. So now the next input has to be, let's convert this capital R into small r. Capital R into small r will give me 8r cube here and 8r cube here. Okay. So pi 8r cube, if I take out common, I'm left with 7 by 12 plus 2 by 3. 2 by 3, so 4 times, so I will get 15 by 12 here overall. Let's see. 7 by 12 plus 4 times 8 by 12. Yes, that is what precisely what I will get here. So I'm getting pi 8. I'm also stupid. I should have taken care of it here itself. Anyway, not a problem. 15 by 12. Is this appropriate? How is it coming out to be such a good number? 7 by 12 is 58.33 and 2 by 3 66.66. No, okay, wonderful. This indeed turned out to be 125. So fine. So this goes 5, this goes 4, this goes 2. So from here I get 10 pi r cube. Wonderful. If it is 10 pi r cube here and 2 pi r cube here, altogether I will get option A, 12 pi r cube. This question is nothing but a simple check of whether you know your formulae appropriately. Next question. The length of edges of a cube is 12 centimeter. An ant moves on the surface of cube from point A to point B along the path shown. The length of the path traveled by the ant is. Now, if anyone has marked option C as the answer, very bad. As in, don't forgive yourself for this error, because look at the distance the ant has traveled. Traveled A here, traveled A here, traveled A here, traveled A here, part of A and part of A, but altogether this also makes out to be A. So the ant has traveled 5A here. One side of the cube is 12. So the ant has traveled 60 centimeter. Anyone who did not read the question appropriately and made the journey from this point, started the journey at this point, do not forgive yourself for making this error. Although this is a simple question, lots of people would make error like this. That is my expectation. If you made that error, please do not forgive yourself. Please read the question carefully. Next, a rectangle ABCD has sides AB and BC of lengths 20 and 15. Okay. So A, B, C, D, this is 20, this is 15. A quadrilateral PQRS is constructed in the following way. Point P is on the side AB 4 centimeter away from it. So this is P, this is 4, this is 16. Point Q is on side BC 6 centimeter from P. Okay, this is 6, this is 9, this is point Q. Point R is on side CD 5 centimeters from C. Okay. R here, 5 here, 15 here, cool. And point R is on side CD 5 cent. Sorry, point S is on side DA 9 centimeters from D. So 9 here, 6 here, and this is PQRS. What is the area in centimeter square of the quadrilateral PQRS? If we are looking for area of quadrilateral PQRS, simply see this. Let me first join the lines. We need area of this. One simple way of doing it is, of course, calculating area of these 4 triangles that are getting created. And from the total area, you can subtract it. The other thing you can potentially see is, can you see SQ is going to be parallel to DC and AB? Or basically ABQS and DCQS are both parallelograms, and you are simply creating a triangle inside it. So this is half of ABQS. This SRQ is half of DCQS. Can I simply say PQRS will be half the area of ABCD? Area of ABCD is 15 into 20. So area of PQRS will be half of this, which is equal to 150. Yes, you can use these portions. You can use these portions and get your answer, but this would also do. Last question. The area of a rectangular field whose sides are in the ratio 3:4 is 97200 square meters. How long will a boy take to cross the field diagonally at the rate of 10.8 kilometer per hour? Okay. So 3a into 4a is equal to 97200. So a square is equal to 12 से काटा तो पहले 8100. A is equal to 90. So basically the field that you have is, this is 270, this is 360. Hopefully you can also see this is 450 now. 3:4:5 because this is a rectangle. So now 450 meters have to be covered at the rate of 10.8 kilometer per hour. This is 450 meters at the rate of 10.8 kilometer per hour. So let's also convert that to meter per second. 10.8 into 5 by 18. So I can cancel this. I can cancel this. This becomes 3. This becomes 5. This goes. This goes. So I'm left with 150 seconds. 150 seconds. Options are in it. Translates to 2.5 minutes. So option C. That will be all for this video. Hopefully you learned something. Okay, bye.